Salutations, calculus students. So here we are. Today we're going to be answering this question. How do you take a derivative if you have two terms that are multiplied? So for example, if you have the function f of x equals x squared times e to the x, what is f prime of x? Like, how do you take the derivative of that? And that should be something that's like pretty straightforward, hopefully, because like those two terms aren't complicated on their own. But what we're going to need to answer this question is something called the product rule. Okay. And this is something that's extremely important for this class. You're going to use it off and on throughout the year. The product rule says if you were to take the derivative, so d by dx, you take the derivative of two functions multiplied together. The way you do that is you do the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, now you can see this written in different forms from time to time. Sometimes they'll switch the order of the second two terms. Sometimes they might write these two terms in opposite order. It doesn't matter. Everything's added together, and then the two terms are multiplied. So the order there is kind of unimportant. The idea is you have the first and the derivative of the second, and then the second and the derivative of the first, and then those are added together. Okay, so let's do some examples here. So suppose I tell you that y equals, let's go back to this one we just did, x squared times e to the x, and ask you to find the derivative, dy dx. Okay, now if I wanted to use this notation that we just used above, the x squared is like your f of x, the e to the x is like your g, and those two would be multiplied together. So if you were to take the derivative, y prime would be, okay, so the first function times derivative of the second, so x squared times derivative of e to the x is e to the x, plus the second function, so the second function is e to the x, times the derivative of the first function, which is 2x. Okay, and there you are. Not really much we can do to simplify, so that's how the product rule works. Okay, let's look at another example. Suppose I tell you f of x equals x squared times x plus 4. Okay, so in this case, this is like your first function, the x squared. The second function there is the x plus 4. So when I take my derivative, let's see, I have the first function, x squared, derivative of the second, derivative of x is 1, derivative of 4 is 0, plus x plus 4, times the derivative of x squared, which is 2x. Okay, so if I wanted to clean this up a little, which you don't necessarily have to, this is x squared plus, and then you distribute this out, 2x squared plus 8x, which you could write as 3x squared plus 8x. Now, that's actually really cool, because that shows you that if you were just to distribute this out, so if you just distribute it out like we've done a million times, you get x cubed plus 4x squared, and then if you take the derivative of that, you get 3x squared plus 8x. Oh, cool. Okay, so by distributing, we got the same answer as the product rule, and that's great because it shows you I didn't just make up the product rule randomly. It actually gives us a result that we would expect and hope for. So that's good. Product rule is good. Let's do maybe one other one, and this is one that's going to be a little messy, but like usual, we won't simplify. So f of x equals, let's say, 3x minus 5 times ln of x plus 2 rad x. Okay. So when I take the derivative, again, this is pretty set up nicely. We have the first part, we have the second part. So the first part, 3x minus 5, times the derivative of the second part. Derivative of ln x, of course, is 1 over x. This is 2x to the 1/2. So we'll use our other rules that we've done before, kind of bring the 1/2 down. 2 times 1/2 is just 1, so that's just plus x to the, okay, subtract 1 from the power, negative 1/2. And plus the second function, ln x plus 2 rad x, times derivative of the first, so just times 3. Okay, and there we go. Again, no need to simplify it. That's totally a fine answer. All right, one thing also you might be looking about is what if we had kind of a constant in front? So what if they gave you the function, let's say, 5x to the 4 times e to the x? And you may be wondering, what do I do with the 5? Well, there are two ways you could approach this problem. One is you could group it together with one of the terms. So have like a 5x to the 4 times an e to the x. So you could just group it and say this is my first, this is my second. So then your derivative there is first times derivative of the second plus the second times derivative of the first, so 20x cubed. So that's another thing. The other thing you could do is leave out the constant in front or pull out that constant. So you could pull out the 5 in front and you have x to the 4 times derivative of the second plus the second times derivative of x to the 4, which is 4x cubed. Okay, And if you distribute, you'll see these are identical answers. So I just wanted to show you this, that you could handle these problems either way. I generally tend to pull out the constant, but whatever makes you happy will bring you success in these. Okay, now, this is pretty cool. What you might also be thinking of, is it possible to do the product rule within the product rule? In computer science, we might call this recursion. So let's say you have this function. Let's say you have x squared times e to the x times 2x plus 3. And I ask you to find dy dx. What a delightful problem. So you could handle this, again, a couple different ways, like with a constant. But I would generally say, here's my first part, f, and then the 2x plus 3 is my second part, g. So when I take the derivative, let's see, I do the first x squared e to the x times the derivative of the second, 2x plus 3. So I'm, again, just starting by, just 2. So I'm, again, just starting this by saying this is a product between two terms. But then what I have to do is when I do the second times the derivative of the first, here's where we get a little bit of a kink in our plans, because we have to multiply by the derivative of x squared e to the x, which we've done already, but that's where we have to use the product rule. So as part of doing the product rule, I have to do the product rule to find the derivative of this first part. So that's just x squared e to the x plus e to the x times 2x. Okay, so that's how you can take derivatives there. Okay, so that's the basics of the product rule. I wanted to give you a couple examples of what it might look like if you have kind of symbolic examples or symbolic functions. So suppose you have f of 3 equals 7, f prime of 3 equals 4, g of 3 is negative 2, and g prime of 3 equals 5. Okay, and I'm going to give you two problems with this same one. So the first one, I'm going to tell you that h of x equals x squared f of x, and I want you to find h prime of 3. All right, so how you're going to approach this first is, like, first thing you're going to write out the derivative. So you're going to write out derivative with f and f prime, and then you're going to plug in. So it's just like usual. We take a derivative, and then we plug in later. Okay, so let's go ahead and take the derivatives. H prime equals first times derivative of the second plus the second times derivative of the first. Okay, so then when I want to plug in and find h prime of 3, h prime of 3 is 9 f prime of 3, 3 squared is 9, plus f of 3 times 2 times 3. And then a smile creeps over your face because you recognize we see those values right there. So h prime of 3 is just 9 times 4 plus 7 times, oh my god, that's a big number. So that's 36 plus 42, which should be 78, unless I screwed something up, which I probably did. But that's the general setup. So we take the derivative here, we're going to leave it just in terms of f and f prime, and then we'll plug in the f values that we have from the table. Okay, now the other thing that we're going to do with this same one, what if I tell you to find fg prime of 3. So this notation's a little weird, this fg prime, but this just means like the derivative of f of x times g of x. So it's saying use the product rule on those two functions and multiply together. Take the derivative of f times g. So we're going to use the product rule on that. So first off, so fg prime of x, so as always, when we write it in terms of x, that's the first times derivative of the second plus the second times derivative of the first. And then if we plug in 3, so it's saying fg prime of 3 equals f of 3 g prime of 3 plus g of 3 f prime of 3. Okay, so we took our derivative again in terms of f and g, and then the last thing I'm going to do is just plug in the values. And again, we know all 4 of these values, right? They're given to us in the problem. So f of 3 is 7, g prime is 5, so that's 7 times 5 plus, and then g of 3 f prime, so it's negative 2 times 4. So that turns out to be 35 minus 8, or 27. Okay, so I hope this helped, and I'll see you guys soon. Thanks for watching.